Hi there! In this video we're going to be learning about solving quadratics using a method called completing the square. Now, if you cast your mind back, we've learnt two methods so far, factorization and the quadratic formula. Those are two methods we've learnt to solve quadratics. Now I'm going to introduce you to the third and final one that you'll need to know. So, like with factorization, there's two different methods for when a equals 1 and when a doesn't equal 1. They don't differ too much, but they are different. I'm just gonna remind you that when I say a equals 1, we're talking about this general form ax squared plus bx plus c, and we're saying that this a here is equal to 1. Or in other words, this is our form. So, for example, we can see that this quadratic here is in this form because there's a 1 as our a. Okay. Now, let's read this question then. So it has two parts, so let's focus on I first. Okay. It says, write x squared plus 6x plus 2 in the form x plus a all squared plus b, where a and b are constants. Now, I'm just gonna point out that this is called the completed square form. Because we use this method to get to this form. Now, so whenever you see this form here, x plus a all squared plus b, you know that you need to complete the square. Right, so, but the question is, how do we get it into that form? Okay, so there's a bit of theory here, so I just want you to consider this. Now, this here, x plus 3 squared, you might be asking, where did it come from? All I'm doing here is, technically, I'm doing this. Writing this. Okay? So, what this means is x plus b over 2, remember our b is 6, so 6 over 2 is 3, and squared. Now that's all you really need to remember. To start completing the square question, you write this out. Now let's figure out what this equals. So x plus 3 squared, well that's the same as saying x plus 3 multiplied by itself. And now we can expand this out. So we get x squared plus 3x plus 3x plus 9, and then we can simplify like so. And now we can notice that this here is very much like this. In fact, the first two terms are identical. It's just the last term that changes. So if I just kind of shorten this here, we have shown this. Right? All I've done there is I've got this left hand side and then this right hand side. And we know all of these things are equal, so I can write this. But what we want is we want this. We don't want this. We want the plus 2 at the end, not the plus 9. So to do that, first off, we can subtract 9 from both sides. So we'll get x plus 3 squared minus 9 equals x squared plus 6x. And to get to this, all we have to do now is add 2 to both sides. Like so. So we get, this becomes minus 9 plus 2, so that's minus 7. And then we have this, right? I'm just going to do that. Right. So now, in fact, let me go back. So now that we've considered that, now we can write x squared plus 6x plus 2, which is what we started with, equals x plus 3 squared minus 7. So we've got it in that form, x plus a all squared plus b. Bear in mind, plus is just a placeholder. We can have negatives still because it's the same as plus minus 7. Okay. So now it's asking us to solve the quadratic x squared plus 6x plus 2 equals 0. Okay. And this is how we do it, right? So now we've got it in the completed square form, so we can say that that's the same as this. So obviously we can use any of the other methods we've learned, but if you're told to use a completing the square, we can use this here to well, in fact, I'll put that there. That is the same as that because we've just proven it here. And then what we do is we can just manipulate it. So if we add 7 to both sides, we get rid of this and we add it. 0 plus 7 is just 7. And now we can square root. So this square root, it cancels out with a square. We get root 7. But remember, we can either get plus or minus when we take the square root of something. And now all we do is we subtract this 3. So we get minus 3 plus or minus root 7. And that means our two values for x are minus 3 plus root 7, or x equals minus 3 minus root 7. And we've solved the quadratic. Okay, so this bit, we just substitute in our completed square form and then just solve it. This bit is a little bit more difficult. It's all about putting it in this form, so x plus b over 2 squared, and then figuring out what that's equal to, and then finding the difference between the two. Okay. Let's look at a case where a is not equal to 1. Well, the good thing is that the method's not a whole lot different. So here we can say, it says write 2x squared plus minus 8x plus 10 in the form ax plus b all squared plus c, where a, b, and c are constants. Well, you can see that it's different because we have this a here. So again, what we need to do first is we need to do something. So when a isn't equal to 1, we have to take that out as a common factor. So let's take this 2 out. So a equals 2, so take 2 out as common factor. So we're going to say that equals 2, and then we're going to take that out as a common factor. So we're dividing that by 2. 8 divided by 2 is 4, so we get minus 4x. We get plus 5. So we've just taken it out as a common factor. Sometimes you won't end up with nice numbers. You'll end up with fractions or decimals, but that's okay. You still have to do this. You have to make sure that a is equal to 1 before you do anything. And now that a is equal to 1, now we can consider this bit inside. So we say consider x squared, consider so now we just want to find the completed square form of this. That's what. So we need to consider x plus, x minus 2 squared, because remember, we divide b by 2 and our b is minus 4 right now, so that's what we get. Okay, and that if we expand that out, we get, well, first let's write it like this, and now if we expand that out, we get x squared minus 4x plus 4. I've done the simplification process as well. You can do it in one step if you're feeling confident. And now we can see that x minus 2 squared is equal to x squared minus 4x plus 4. And that's almost equal to this, what we have here. We just need to add 1 to it. So let's add 1. So you can subtract the 4, then add the 5. But if you're feeling, if you feel comfortable with them, you can always just say, yeah, I only need 1 more to get to this. Okay, and now we've got that. So now we can say, alright, so x squared minus 4x plus 5 equals x minus 2 squared plus 1. But remember, we don't want that. We want 2 times all of that. So we just multiply both sides by 2. So remember, we multiply both of the terms by 2. And then we can just put this back into its normal form. And there we go. So this is our completed square form. Now it says, what is the turning point of the quadratic? So I am going to sketch it as well. Now last time we learned how to find the turning point, but there's actually a way you can find it using the completing the square method. So if you have ax plus b squared plus c, turning point is minus bc. That's the turning point. What does this mean exactly? It basically means that if you just get the completed square form, and you just reverse the sign of this b bit, and then you keep this c, and you have the coordinates of the turning point. Okay, so let me do that. So now we have the completed square form, this. Now our b here, we can see it's 2, minus 2, sorry, and our c is 2. So now we want minus bc. So turning point is, well, minus b, so that's 2, and just c. So it's 2, 2. And we can put it in here. Like that. Okay, so have a go at this exercise. It's only one, but it's quite a long one. You should use all 3 methods, factorization, the quadratic formula, and completing the square, to solve this equation. And then sketch the graph. This is the graph y equals 3x squared minus x minus 2. And find its turning point. And I want you to use the completing the square method for the turning point. Yeah, so you should get the same answer for each. Okay, thanks for listening.